Hi, good morning to everyone. In this video, we are going to see about pipelining and superscalar techniques. We know the meaning of pipelining. Pipelining is one of the technology where to achieve the parallelism between the processes. If a system consists of n number of processes, means in order to achieve the parallel computations between the processes, pipelining is one of the proposed technique where it follows some pipelining stages. What are the pipelining stages? Means fetch, decode, execute and write back. So these four are the four important pipelining stages involved in the pipelining technology. That and all we have studied in the previous semester also. In this video we are going to see about the pipelining with some detailed explanations with two types of pipelining processes. What are those? Means linear pipeline processes, another one is non-linear pipeline processes. The another name for linear pipeline processor is static pipelines. Right? Similarly, the another name for non-linear pipeline is dynamic pipelines. Let us see the topics one by one. Linear pipeline process. So, linear pipeline processor is a cascade of processing stages where it is connected linearly to perform a fixed function. Right? So the definition is clearly mentions that it is a processes which are arranged in a cascaded stages of its pipeline. Right? The stages of pipeline are arranged in a cascaded manner, and these stages are perform a fixed function. Okay? So this is about the linear pipeline. Right? So the linear pipeline is a pipeline in which the series of processes are connected together in a serial manner. In linear pipeline, the data flows from first block to the final block of the processor in a linear way, in a serial way. The processing of data is done in a linear and sequential manner. Okay, fine. So here there are two types of linear pipelining stages are there. One is asynchronous type, another one is synchronous type. So what is the asynchronous model and synchronous model means? In asynchronous pipeline model, the data flow between the adjacent pipeline stages is controlled by a handshaking protocol. We know the meaning of asynchronous. Asynchronous in the sense the fixed pipelining stages will not be done in a fixed clock cycle. It may vary. In synchronous pipelining, these stages will be carried out in a fixed clock cycle. But in asynchronous, it won't be following a fixed clock cycle. So the pipelining stages will take varying number of clock cycles. How it is controlled means it is controlled by a handshaking protocol. Okay, then. So here this diagram shows the asynchronous pipeline model. In the first diagram shows the asynchronous pipeline model. Here number of stages are there. These stages are called as pipelining stages starting from S1 to Sk. In asynchronous model, there are two signals are used. One is ready signal, another one is acknowledge signal. Okay, so here ready signal is nothing but it only started communication. So this ready signal is sent from external input devices to the first stage of pipelining, right? So to the first stage of pipelining, the ready signal is sent, it is assigned from the external input devices, because input devices is the starting of communication, right? So from the input devices, the ready signal is sent. Once the stage 1 is performed and it is completed as execution and it is processing, then it will release the ready signal to the another stage of pipelining. Once the second stage is ready for its execution, in the sense for its processing, then it will send a acknowledge signal its previous stages. Okay, so it will be sent to the previous stages. Likewise, this ready signal and acknowledge signals are performing for each stages of its pipelining, right? So here input signal for the first stage is given from the external input devices. Similarly, the output signal is sent from the last stage of pipelining to the external output devices. So this is what happening in asynchronous mode of pipelining. Okay, asynchronous mode of pipelining model follows the two signals. One is ready signal, another one is acknowledge signal. Right. I hope you understand. The next type is synchronous pipelining. Synchronous pipelining is nothing but every stage of pipelining will be done in a fixed clock cycle. Here there is no need of ready signal and acknowledge signal. Instead, there is a one time delay is allowed. It is called as latch. So this latch is acted as the interface between the pipelining stages. So latch is say for example, if you take S1 and S2 two stage means here latch is one of the time delay is assigned for in acting as an interface between the stage 1 to stage 2. So what it will do, what is performed in latch mean, it only does the transfer of data from one pipeline stage to another pipeline stage, right? Say for example, S1 is for fetching stage, S2 is for decoding stage. So right after the fetch one stage, in order to move to decode stage, the data should be transferred to its second stage. This data transferring is done in the latch. So this latch is following a fixed clock cycle. That's what it is called as synchronous pipeline model, right? I hope you understand, right? Fine. The next one is reservation table of 4-stage linear pipeline. Here this is called as linear pipeline. If you take linear pipeline, how the reservation table is made according with the number of stages with time clock cycle means, here linear pipeline is having a sequential execution. That means sequential stages of pipelining, right? After S1, S2 should be carried out. After S2, S3 should be started. After S3, S4 should be started. Likewise, for each clock cycle starting from S1 to S4, it is showing, right? Then, what is meant by pipeline throughput? Throughput of a pipeline is defined as the number of instructions that can be executed per unit time. Okay, so pipeline throughput is nothing but it is a count. It is a measure of measuring how many instructions are executed in a given unit time. If you want to measure it that time with hours means how many number of instructions can be executed in a hour. If you want to measure the throughput in times of seconds means how many number of instructions can be executed in a single second. It shows the pipeline throughput. Fine. So if you take one pipelining stage, what is the optimal value can be reached means, the right side it shows one diagram. It is drawn with respect to the number of stages and also performance cost ratio. Okay, y-axis shows the cost ratios and x-axis shows the number of stages. So starting from when the number of stages are lower, cost is also lower. When the number of stages are increasing, cost is also gradually increasing. When it reaches its one optimal level, when its peak level, then when the number of stages increasing but it is gradually decreasing, the cost is gradually decreasing, right? After reaching its peak level, it is performing in a vice versa. But the number of stages are increasing but cost ratio is decreasing. Okay, here this level, peak level is called as optimal level. So this optimal number of stages are the advisable number stages for a one pipelining stages. Nonlinear pipeline processors. So we know the meaning of nonlinear. Nonlinear will be taken in a non-sequential way, right? So these will not be taken in a non-sequential way. So how it performs means, this will be performed, performs multiple functions. It will performs a multiple function. It also has feedback and feed forward connections. It also has feed forward and feedback connections. It is made such that it performs various functions at different time intervals. Here this nonlinear function is called as a dynamic pipeline. Why it is means that it can perform a variable functions at a different time. So there is no fixed function is allowed in a pipeline, in a nonlinear pipeline. So that's what it is called as a dynamic pipeline, where it performs various functions, variable functions. Here it shows the three-stage pipelining starting from S1, S2, S3. Here two different functions are performed with the help of three-stage pipelines. So what are these two functions? Means X function and Y function. Right? Here if you see the diagram, the input is given from the external input devices to the first stage, S1 stage. After this execution of that input function X, the output is given out from the S1. Then one more copy of output function is given to S2. This S2 is carrying the decode function, decode out stage. Then it will be given to the S3 function. So this is what happening in the three-stage pipeline function. When you see the reservation table for the dynamic pipeline for the previous design, so when you take the function X, so what will happen first? For the first clock cycle, it is done in the stage 1. In the second clock cycle, similarly it is done in the second stage. Third clock cycle, it is performed in the third stage. After that, what will happen? Because the output of S3 is given as a input to S2 again. So what will happen after the third clock cycle? At the stage of fourth clock cycle, S2 will perform. S2 will start its perform. Then S2, output of S2 is given as input to S3 again. So again S3 will start its communication. After the second part of S3 is over, again S1 will start its communication. Like this reservation table is made. Right? I hope you understand this video. I will catch you in the next video about next types of pipelining techniques. Thank you.